Now, let's solve an equation. So, which is the actual thing we're doing in this lesson. Let's solve an equation. So, how do we represent this equation as a bar model? And then from the bar model, we're going to write the fact families and we'll try to write a function machine. So, let's check this out. Let's see what we can do. So, as a bar model, we can write it like this. So, the big bar obviously will be 17.3, right? And then we have x because that's what it's telling us. If you just think about it, common sense, you figure this out. You say, okay, that big bar must be 17 at 17.3. And then these two bars should be x plus 8.4. The size does not really matter because we don't know what x is, do we? We don't know. So I want you to think, how many fact families can you write from this? So pause and write your fact family. How many of them can you write? Remember, for this, you can write 2 addition and 2 subtraction. I'm just giving you a hint. Okay, I'm sure you would have come up with these. Yeah, so the first one that is really obvious is the equation itself. 17.3 is equal to x plus 8.4. And then remember, addition is commutative. So we can, swap 8.4 and x, okay? And this will be the second one. That's fairly obvious. And then the subtraction, the way to do it, you can say, okay, what if I can take a slice of x from 17.3? Yeah. How do I write that? I can write that as 17.3 minus x equals 8.4 because that's what is going to be left. That's how you would write it as an equation. If you slice off that bit, and it's the same for the 8.4 bit. You say, okay, if I can slice off 8.4 from the 17.3 bar, I'll be left with x. So the way to write it as an equation will be 17.3 minus 8.4 is equal to x. Now, if you take a look at it as a function machine, yeah, we're putting in x, we add 8.4, we get 17.3. If you have an output, but you're looking for the input for a function machine, what do? Inverse operation, right? So we do that. So instead of adding 8.4, we do subtract 8.4, and we get exactly the same result that we'll get here.